Today, I will be presenting my area of focus that was under Concordia University's staff research that was ongoing on campus. I'll start by talking about what staff is, and then we'll go into what the research is actually looking at here on campus, and then I'll go into what my specific area dealt with and some of the data and conclusions that I was able to come to. So Staph aureus is a bacteria, and it's commonly found in the nasal passages of people that are in the population. We found that roughly 30% of people carry the staph, although it exists commensally, which means that it's not actually causing disease, as long as it's remaining in those specific areas of the body. The staff study here at Concordia is looking to collect nasal swabs of people that are here on campus, and then we're conducting testing to see if the staph is actually present. We're also collecting a survey when we swab people's noses, and that survey is including questions like if they've traveled recently, or if they've recently used antibiotics, if they participate in sports, just to name a few. And after isolating the staph, if it's present, we have sent out 150 samples of these strains to the University of Minnesota so that we could have their genes sequenced and gather the genetic data on these samples. With this sequencing, now we are able to look at a sample size of our staph strains and cross-reference that genetic data of those strains against the survey questions that we had asked. And what that will do now is lead into what my specific area of focus was for this research. What I sought to do was to look for any correlation between someone who had recently used antibiotics and whether or not there was. All right, so now that we've talked about some of the background of the study and what my specific area was seeking to do, let's talk about what the data actually ended up showing. So by cross-referencing the genes that were found in those 150 samples that were sequenced against the survey question of whether or not people had used antibiotics recently, what we found was that recent antibiotic use didn't actually appear to influence the presence of those resistance genes. Both the BLAZE and the MECA genes were present at roughly the same percentage, which was about 50. And this was regardless of whether or not someone had used antibiotics recently. To say this in another way, the BLAZE gene is going to be present at an average of 50% of strains tested, and the MECA gene is going to be present in an average of 1.7% of strains tested. And again, this is the same average whether or not people have recently used antibiotics. Let's talk about some of the things that these results might mean and what it means for the research behind staph at large. So one thing to note is that for the MECA gene, the sample size was considerably small. Only 5 cases were actually detected of that MECA gene. What these results do indicate is that regardless of antibiotic use, there is a persistent presence of these resistance genes present in Staph aureus. The reason I wanted to look at this particular question in the first place is because it's a well-known fact that antibiotics when overprescribed or improperly used have been shown to increase the number of these resistant genes and these strains of bacteria that are much more difficult to treat. And what I believe my research is illustrating here is the dire need for new Staph aureus infection treatments, because we're now seeing that whether or not someone has used antibiotics is kind of irrelevant. These genes are going to be present no matter what. So I do believe this highlights the great need that we are in, because we are running out of drugs essentially to treat these methicillin-resistant staph strains. This is showing the direction that the research really needs to be going, which is how can we develop new drugs that are able to treat these, and how can we get out public messaging about antibiotics and encouraging people to do things like finish the full round when your doctor prescribes an antibiotic, and finding other ways to treat so that we don't have to rely so heavily on these antibiotics that are becoming less and less effective due to these genes. With that, I want to thank you for your time and listening to this presentation, and I hope you have a great day.